Adam D here. Going to be continuing our look into barb-metal. This is a challenge we've been working on. This is the third time I'm going to be continuing this from DEF CON 2021 finals, and it's an attack defense CTF challenge. A little bit of background. It said the OOO's new IoT platform, Ruby on Rails, no Ruby on bare metal x86. This challenge has no flagment. Okay, that doesn't matter. We've been reversing this, so we have our commands here that we've reversed from first we had to reverse engineer the binary, and then we had to figure out the payload format, so we've been doing that. So up in this top is all the Ruby bytecode that is the payload that gets executed. This is everything that we need there. And yeah, so we have this, we have the commands. Oh, we also know the other really important thing is, well, the very funny thing is, since I left this, apparently this Firefox instance running, and I guess this thing just keeps asking if it's armed and not armed and armed and not armed, and keeps talking with this thing. So much so that it used 128 gigabytes of memory, which is never very fun when that happens. So anyways, tons of fun memory usage there. But let's just keep going. We're going to, yeah, we're going to go into here. So my intuition here, where we are right now, so this is the main verified payload function. We actually probably don't care about this because, again, the verified payload is probably only to allow us to actually patch the file. So we have to find a vulnerability in here if we ever want to patch, which is actually a really cool way of designing a challenge such that it's difficult to patch. And then we have our execute payload. One of the cool things that we should have, not so my IDB was corrupted, so that's no fun. Okay, great. Shit, I may have to redo these names. That's okay. Let's see up here. So we have these classes that we found that last time we were looking at naming. So we saw that these are Ruby objects that are actually being created. Ah, man, that's annoying. Okay, I don't have to name these things again, but that's okay. Right, that's not it. That's it. Thermostat new read. Remember, these are functions that get called from our Ruby code and actually go into this backing like x86 code here. So we're gonna have to do that for all of these. It's gonna be really annoying. Oh, that's right. Base 64 was also is a and that's why we weren't actually able to run this in our local instance because of this. So it's a new. I know I'm naming these with a different scheme. That's okay. This will actually make searching for them a little bit easier. I wonder what this is. Probably like the instance variable maybe, or something, some kind of class. I don't know. But that's okay. UART. See, now that's weird that we can't find this UART. I bet. Maybe that's a weirdness of how it's finding variables. Oh, you know, let's go to the base 64. Nope, not there. Oh, that is where I wanted. Bang, bang. Let's see, base 64. So these are all kind of global base 64 class. I'm just trying to look to see if maybe it didn't get the UART or something in here. I suppose I could. Oh, there's alarm, new info, armed, arm, disarm. Thermostat, UART. Oh, there we go. Why didn't that show up in my list of strings? That is weird, but now UART new. And how do we get to the UART? I wonder if this is the thing that it's using to do the read and write. We can check that in a bit. But that's actually interesting here that we found these. So we have this, we have the UART, we have an alarm. This alarm new. info arm disarm. All right, thermostat. And let's save this database because last time it crashed because of that memory issue I was telling you about. Okay. Oh, I already did thermostat. Great, smart speaker. Okay, smart speaker, boom. Nope. Smart speaker. XRF that, boom. New. Oops, that says thermostat, which is not the same thing as a smart speaker, apparently. All right. That add, play, vote, queue popular. Ugh, just name it. What the hell? What do you care what the name is? You're just a decompiler. Disassembler. Whatever. Okay. So I think we got all that. Let's check. I think that's good. Okay, yeah. So we have the smart speaker, base 64, alarm, UART. Cool. So let's see where this UART gets called now that we actually know where that code is. Ah, the gets method. Ah, okay. So this calls gets right on our input. Okay, let's check this because this is where our input actually goes first. So our input goes in through here. So if we go back here, we can see this new. So the problem is these functions are not, I don't actually know what these are yet. This is a bit of a pain. There's no debug info in these things. These are probably like Ruby stuff, like getting, I don't know, initializing something, it looks like. That's probably like initting something into there. Setting A2 to be B30, A1. So this looks like some struct that is the smart speaker that we're creating somehow. Calling some other function. Returning result is V4. V4 looks like to be what is whatever that thing points to. All right, well, we can ignore that for now. We may have to dig in and figure like, but remember, we do actually know the code of this because we figured out where it was in mruby, so we could probably suss out and figure out where these things are as long as we can see what the other things that we have named. Oh, the other cool thing you can do is, some people don't know, is depending on where this is. So usually, I think most of the time, I actually don't know. What's this, 11.5e? So, wow, very high up, 11.5. Let's see, 115. Yeah, whatever, 115E24. So the cool thing is how most compilers work. When they compile a file, they compile each of the files in order as you see them here. So actually the layout of the functions that you see in the disassembly here in these function names is actually usually in order. So if I went to mbrc alloc raw, probably the other functions would be the ones around there. So that's actually how you can map, if you know the source code, you can map them into these functions. You do have to watch out when functions are inlined into another function so they don't appear here in the function name list. But so you want to actually verify by looking at those function names. But that's kind of a in-depth process, and we'll only do that if we really need to. But let's see, what do we do? Get IV, call read. So the very first thing we do is call IV read. So let's not care too much about new. And let's go back to our fun UART. UART read. Because it first calls read. And then, let's see. Word load I jump if equals. load immediate 13. Is that what that means? I don't know. Jump if. Let's move that there. Okay, move. I don't really know what this does, but that's okay. It's weird that it does read. And what about gets? Wait, yeah. Where's... Oh, gets, though, is this method. But it's weird that UART has a gets method and this has a read method. But let's check this out. So, okay, here's UART read. Cool. So we see that this MRBC raw alloc. And again, this is custom code, so we can't try to map this to anything here. So we have custom code here. So we're allocating probably size of something, some size. Let's see, size something. Oh no, it's a pointer to something. Ah, so it's an allocation. Pointer. Let's see, read, return. If we work backwards, it's returning some result. Here it's a 2. Oh, weird. Maybe this is a string, like a reference to something, so we're calling read. But I'm not entirely, or the UART object. Okay, jumping here, calling something. Okay. Wow. Says a lot of junk. Okay. Alloc C. Setting up, creating some structure, it looks like. We don't exactly know what that structure is. Oh, cool. Okay, so great. This gives us some information. So now we can actually start to, because I want to now, anything that I kind of pop into and I see that this is clearly an MRubyC thing, that I want to MRubyC source. Then I want to give it a name so that then when I see it again, it won't be so confusing. MRBC deref. Let's see. Object. Oh, yeah, here we go. But this says it's dec. Yeah. Okay, so pointer decrement reference counter. Okay, so this we probably don't care about. And okay, this actually frees it when it's done. Hopefully there's not a bug in here that we have to figure out, but maybe. It's always possible. But okay, so we're decrementing the reference, and there should be somewhere where we're actually like incrementing a reference. Let's just pop into some of these. I think I already did this, but we'll see if any of these invite. Okay, I think this is like read, is hardcore like read instructions. This is actually, so we know this is calling read somehow. Okay. So somebody else calls increment reference then? Okay, so this is a pointer and v10 must be, is this likely a size input? Oh, just tell me. Okay, so size input. Oh, okay, so if we're setting up UART underscore read, I wonder, have I ever just tried that, or just eating in a bunch of values here? Let's see. Oh, socket already closed. Invalid. Because it looks like it's allocating this thing from here. So UART read, let's see, size input maybe +1. Yeah, this is going from A2. This must be our UART object. Okay, and I bet if we went into UART new, what the heck? Okay. That's interesting. I have no idea what that does. Why it's weird like that. Wait, what? Why isn't this call shown? Oh, it's a null return address. Okay. Anything interesting it gets? +4 was that interesting offset here of this object because it gets the size, it allocates it. It's into a pointer. This is probably read, right? So this is the size. This is something like get car, A1 plus plus V3. Yeah, so something like read. Yeah, so this is reading from standard input, I think, the size there into that pointer. And then this probably. Okay. Some kind of, okay, so pass in the address of V6, A1, pointer, size input. A1, returns A1. Okay, allocate V6. Okay, again, another setting up some kind of object. No idea what it is. Dereference it, UART object is result. V3 is UART object, V4 +1. UART object. Okay. It's like C++, where we have to like define the structs for these objects based on what we see them doing. What was V3 is V6. V6 was what? Although I guess we can see here 100 V6. Oh, V6 is whatever gets passed in here, which is A1. Star A1 is equal to 11. Oh, but that's a struct too. Okay. All right, cool. Well, don't see anything super interesting here. I don't see gets being called in UART, but okay, then let's go back to here. Okay, let's see other things that were interesting. So therm, do therm. So this method, let's see, splits the input based on space, and then the command, if it's read, then it calls get therm. And I think the other thing is it passes. So the other thing that's interesting to me is if we remember and look at the notes, we could see our therm is pretty complex. Therm read date Friday, but kind of glancing at this disassembly, it doesn't seem like the disassembly is actually doing a lot of parsing here. Although I guess I should check the Ruby split method. Because what I'm worried about, okay, so it does split an array. Okay, so splits on space looks like load I1 into R6, send R5 bracket, string, boom. If this is equal, if R5 is equal to R6, then if not, jump past this. So this would be all the read stuff. So then move line, which looks like our R1 is our local variable. Oh, cool. Line, so then send, I think it just sends the whole line straight to into temp. And then move that into command. Cat. Okay. Get therm. Sorry, this is where I wanted. Okay, get therm. So yeah, so it sends line, I believe, into get therm. So then let's look at get therm in here. Oh, this is actually in here. Okay, split on space. Oh, that's right. Okay, so it is doing a lot of parsing here. So, okay, where does it actually get? Okay, that's interesting. String equals invalid time. Okay, it actually is parsing it here. And then it finally calls therm and read, and it moves time and date. Okay, so if we go here, we do thermostat. Let's check the new just to see that it's roughly the same. Okay, this is actually more interesting than our other one. It's calling methods. Stuff's happening, man. Oh, there we go. Okay. Lock.c. Okay, great. There we go. alloc free raw. We got another name. With star pointer. So yeah, okay, this is freeing an allocation here. This means our the file raw alloc. Great. Okay, we'll definitely see that again. Raw alloc. Okay, we're seeing +4s. Interesting. Okay. Other stuff. Calc index, great. Okay. So here, maybe let me see if I can. Oh, interesting. That should be inlined, but clearly it's not here. Okay, crazy. Okay, I just saw it in here. Let's see, this is sub 1145A0. Okay, so let's see if I can. Let's see, 45A0. Okay, that's there. Calling calc index. So now I can check here where all the places that I call, or actually what I can do and show you is let's go to calc index. Okay, bump there. So calc index, let's see. So one thing you could do is check out the functions above or below it. If not this, return 8. Yep, this looks exactly like that function. So I can actually, oops. So now I can do that, and then we can look at the one after, after calc index. So calc index, this was add free block. So we can use actually the locality here of, hopefully you're seeing that now. We can use the locality here to say this is probably remove free block. We can see the calc index here, calc index, and so we can do. All right. Split block. But here we're like deep inside all of the memory management and all that stuff. And we actually know that because we have the raw alloc, and so we can see here where we are, which is cool. So now we can purge block. Oh, and then other cool things. So like calc index here, of course. So if I know where this is, right, then I can look at, it has one function call, it looks like. Oh, but I actually already renamed that. No. Oh, that's 16. And then I'm getting a lot of information. So if I super cared about this, I could just keep doing this. And, but I kind of don't. Although, let's see, we're here. Okay, I guess I don't know. Cool. Oh yeah, this is base 64 stuff. I guess this would show me wherever this is called. Well, this is in start. Ah, okay, cool. Okay, so okay, these are all the things that it needs to do here. Initialize UART. Initialize base 64. These are just adding it to basically like the current environment so that we could do it again. I mean, I obviously don't need to do this. But I kind of like this. This is what feels like making progress when you're doing reverse engineering. Okay. Okay, cool. So those are all of our init. Decgraph. Didn't I already do these things? Do each of these have their own name in here? That's interesting. Oh, maybe it's not Decgraph. Maybe I'm Okay. Well, in my defense, these two are exactly the same. Why in the world would they be exactly the same? That's so weird. It's because it's a macro that's just getting compiled in. I don't know, but it's weird that there's one all the way down here and there's one way up here. Up here. Huh. This is like UART specific stuff. Why? So thermostat, does thermostat have the same weird behavior? Yep. Huh, for each of those? That's so weird. So would this be an alarm one? Yeah, it's called in all the alarm functions. Huh. Okay, weird functions around. Smart speaker. Hmm. Okay. So much of the same code. Okay. Let's see. What are some other interesting things we could do? I guess one thing that we could do is also just you could try buzzing this base 64 decoding. So A1, is that even used anywhere? Yes. Here. Okay. Two. Okay. Huh. We're seeing this pattern a lot. exactly is the real base 64 decoding? Probably in here, maybe? I don't know. Okay, let's give up on that. All right, where were we? We're looking at thermostat. So let's say read. So thermostat read. So if A3 is equal to 2. Hello, how's it going? Reading from the thermostat. I wish I knew how to map up. Okay, where's the disassembly? Let's look at it here. Read. Date and time. I wonder if these are objects. Maybe. I think these would be integers, but I guess they're integers. They're Ruby integers. So, okay, so these maybe are the arguments or argument. I guess we could look up how to write this in mruby. That could be a good idea. But just looking here. Okay. This should tell me where it's actually reading from the thermostat. So I don't know if it's actually, because let's see, is it calling any functions or anything? Calls that, which we don't care about. For. Okay, it looks like, okay, it looks like it's just setting memory. So it's setting, okay, A2 plus 28 2 times. Is there a program that can remove a virus impersonating the system? That's from the chat. Yeah, let's see. I mean, it depends on what operating system you're using. I'm sure there's, usually I think Windows has a built-in good virus detection system. It's called Windows Defender. The Mac, I'm not sure what's good, but I'm sure you could use something reputable. Yeah, just make sure you're using something good. Yep, of course, happy to help. Okay, decrement. So this must be our thermostat. Okay. Why should we return that? Who cares? Okay, but thermostat plus 4. Send to breed. Okay. Maybe write makes more sense. Do therm. Keyword was set, so set therm is the thing in here. Guess I did not define that. Okay, set therm looks very similar. Time, date, compare, looking. Okay, puts debug. Okay, then it calls write with time, date, temp. Move into R4. Should be. Yeah, local variable names. Okay, variable names. R4 is date, so move 9. Call write. Send that write to R7, which is therm. Okay, so writing should be, let's see if these are the same, and we said this is decrement, so it means the second argument should be our thermometer. Okay, so our thermometer structure, and where the heck, if I was the thermometer structure, this is probably some context or environment variable. Okay. What I really want to know is how these are getting compiled down so that we can start building structs for them. We could say something like, okay, the thermometer plus 40 is, that's what this value is. So like writing to it. So this is what's crazy. Okay, so get thermometer plus 40 V6. Thermometer plus 28 is V5. Thermometer plus 4, dereference that, plus 16 is V4. If thermometer plus 16. Okay, so this is indexing into something. If thermometer plus 16 by 2 times V5 plus, okay, is equal to V6. Well, I guess we are setting, okay, so let's think about this. What are we setting? We're setting the time, date, and temp. So, yeah, so time, let's see, where are our notes? Yeah, read day, Friday. Oh, I guess I don't know what else. Let's see. Oh, day and night, I guess, are the day and night. Okay. So we can set either a day temperature, a night temperature. Let's see. Let's look at the mruby. Where I am. What I'm looking for here is looking for, okay, how do I compile device classes? Let's see. Ooh, added UART 0 for console. That's interesting. We already have a UART class. I wonder if this is the same. Let's check this. Oh, this would be great because then, okay, yeah, here's our thing where we define the class UART, MRBC class object. I bet that's the same thing here. New, read, gets, puts. Okay, this is sweet. So we have an example here. So now we can go back to our UART guy. Yeah, so this is used all over the place. I'm going to declare that it's this MRBC class object. MRBC define class. I don't know why I'm doing this. I just want to. Oh, yeah, this makes sense. So calling define class, which is what it's doing here. And then this is, as we expected, define method. With this UART new UART run. That's great. Okay, sick. So now we have this init UART method. Interesting that we didn't need the VM, but so then new. Let's see. Default 1 origin. I have no idea what that means. argc is 0. num. So this one doesn't actually return. I wonder if this means it's an instance variable, just returns null. Okay. So this is clearly not exactly the same, so I may be barking up a tree, but at least now I can compare this with what I see over here, so that way I can start to see, let's see this CUART read. Okay, yeah, so we don't exactly know the parameters. We know, okay, this makes sense, this is exactly what we thought. So the first argument is this VM. So this is always the VM variable that gets passed around. So this is some context that defines the pointer into the virtual machine. Okay. And then M, RBC value V. Oh, this is a... not a UART object, but MRBC value. Okay, so what does it do? Okay, calling stuff, buff MRBC alloc. Instead of alloc, it calls raw alloc, so it probably doesn't need that. Needed length. Oh, get int arg. Sick. Okay, so we can find those guys. Let's see here. Okay, I'm in the grep. Okay, sweet. So these are, is this V? Okay. This is great. It's getting us unstuck. I can feel it now. So value type. Okay, what I'm looking for is what is this type? Where is this defined? This MRBC value. It's got to be defined somewhere. You can't be defined nowhere. Let's see, H files are usually good. Convert it to double. No, I don't care about that. C object. String new, interesting. Okay. Where the heck is if, let's see, can I just have it try and figure it out? Heck yes. Okay, type struct R object. So an R object struct, and this is sweet. Okay, so use float. I'm gonna say we are using float. So the cool thing is we can pop this into IDA and tell IDA, well, actually, notes. Okay, so types.h. So the problem is if you try to pop that in there, that would not work. I wonder if I could just include this value.h. What does it rely on? VM config. I don't want that. Okay, sick. Okay, so this enum's always good. Okay. Okay, so I got that type, this first MRBC V type in T. Why would it be in 16? God damn it. Okay. I know it's 32-bit, so I can just hard code that in there. Okay, so that's that type. The float type. I bet we do have floats, so let's just include this bad boy. If use float is 1 or 2, a float, a double, or oh, I see. Let's say it's here. And then we'll try to understand if it's not. Okay. Okay. Get that. Let's get this. I'm sure there's a better way to do this, but I'm in it right now. Okay. Our class. Okay. Type tests. Yeah, I want to know where that struct is. Let's see, our instance, our proc. So this is just saying it could be any of these things. I think for now, let's just call this, because it is a union. A union just means it can be any of these types. So let's, on our instance, I'm just going to call it a void. Okay, and let's now, I think with IDA, I can just import this C file, load file, parse C header file. And let's see if this works. CTF, nope, that was this last weekend. I called this Old Charles, barb-metal types. Compilation successful. Cool. So now I should be able to then, this is actually not based on what we saw here. So now all those types are loaded into IDA. IDA knows about all those structs that I created, all of the enums and everything. So now I should be able to change this to, let's call this args. And let's call this syntax error MRBC value. What would that be? Okay, view. Let's see, I want the debugger view for local types, our object. Where? Wait, so all of those. Oh, that's because this R object. And if I go to here, I go. Yeah, I missed this type def, so. Okay, file, load file. Okay, now I have this type def, so now I can call it an MRBC value because I know that's what it is here. Cancel. MRBC value pointer. Let's see if I can do this. It's better like this or like that. Yeah, okay, that's fine. Okay. And okay, so it also doesn't return anything. Sweet. Okay. Yeah, so this is, okay, so get like args. So this is getting args2. And so let's see if I was get int args. So now we can go look at this macro. This is what in value, I think. Yeah. Yeah, so all this does is like .i is going to be referencing it as an integer, I think. Wait, get int arg. Oh, v, because it defines it as v. Yeah, that's stupid. But whatever. So get int arg, so get v, get the nth element, so get the first 0, 1, get int arg, and this would be casted as an integer. This would be get tt. I don't know what tt means, but interesting. Okay, so just treating it as different ways. What? But this is an MRBC value. What is the dot? Let's see. Ah, there we go. Ah, okay, dot I. So this means it's an integer. Great. So now we actually understand how this works. an object, a class, cool. And we can refine these types as we go along if we need to. But okay, so now we got this awesome stuff like mixed in here. So now we can see this is arg. So int arg1 is the first. So 0 is probably the object that we're dealing with. And let's map this into here. So, okay, so disassembling this. Read. Okay, oh, I'm in UART read. Let's go back to thermostat read. V, so it's just going to be V, and the type of V. Yeah, great. So now these are this, and I don't think we ever return anything from here. Cool. Okay, so if A3, that's argc. So we saw that in this example. Hello. That this is the number of arguments, so that gets passed. So if we go into here, great. So if we call thermostat read, we apply 2 arguments to it, then we get v3.i, v0i. So v0 is not probably I, it's probably treating it as something else, as the V, yeah, 0 is probably the object because it's the thermostat object. So now we actually know where in here are the thermostat objects, which is very helpful. Cool, plus 16. But that also gets dereferenced. So if it's 2, if that, then dereference. V4 and VI is equal to high byte. Huh. I wonder how it does return values. Let's check. Let's look at the code. Set return. There's ret. Okay. Let's see. How does this stuff return? Okay, for call, okay, set return, set nil return, set false return. Okay, yeah, because this makes sense in Ruby, everything has to return a value. So set return, mr_bc value nn is equal to n. Oh, this is sick. So this is exactly the macro. Man, I wish. Is there a way to IDA define macro? No. C macro. Yeah, so I need to write a hexphrase plugin, which I'm definitely not good with, but this makes sense. So this is the exact thing that we were looking at. So we saw this decref 0 is equal to the return is 4, and then yeah, cool. And then why is this VI? This is V dereferencing it. It's equal to V3. Why is that? Set that to 4. I think this is supposed to be the return value, but I'm not. Let's check here. Okay. See. Okay. Okay. I don't think this. I'm just trying to imagine what this code looks like and why it looks like return NNN. Okay, this value is equal to n decrement v. Oh, okay, this makes sense. So this decrement v is always in there, right? Every time we see this, we know we're going to return. Okay, and because v is the value that gets passed in here. Okay, so if we write 3, then int v5. So taking the 5th value, treating it as an int is v5, v3.i. So what were these structs again? I know we just did them. Types.h. Ah, because of this mrbc v type tt. Okay, mrbc type 0 is empty, so that's what that. Ah, okay, so I think then, okay, so this decrements this. It sets the type. Ah, okay, so v0 tt. Okay. Okay. So this is setting the type to be 4. 4 is an integer. Cool. So I can actually, it's not treating it as a byte. I mean, it is, but it's actually dereferencing the, let's see. It is a struct pointer. No. Let's see. No. Let's see. The other thing I'm not good about in IDA is doing enum. Oh, there we go. Enum. No? What? Don't I have these local freaking types that have all this? Yes, import that into the database, obviously. I can, oops, nope. No. There we go. Integer. There we go. Cool. Okay, so that's setting the, I don't know why it decompiles this, but this is setting v.tt. So setting the type of that to be an integer and returning 0. Okay, so all this is to say return 0. Wow. Okay. Right. I see. I remember this was the VM. Doesn't matter if we're sending 3 arguments to write, then v5. Okay, so 0 is the return value. 1 is something. Then 2, 3, 4, 5. I don't know. I'm not sure where the 3 comes from, but anyway, so we're getting int argument 5. That's interesting. Why is that? It's v5. And then, oh, this is the type though, right? That's the value we want to write for sure, because thermostat write. And so v3 is probably is I. So I hate calling it v. Let's call it arg. Okay. So if there's an arg2, then 2 times I plus v3 plus 1 equals v5. Well, let's see. When I did therm write, I had those in my notes. Okay, set thermostat to 10. Set thermostat to 0. Well, this could be used to leak memory or something. So it's checking if argc is 3. But that's accessing arg5. I guess I don't understand. Let's check this again, that example. Let's see, does anybody actually reference argc? So argc is 0. Okay. That's it. Okay, it's just weird to access 5, 3, and 2. Then the difference here between these two is a +1. Oh, so if it's a day or a night is probably, yeah, day or night, 1, 0, and then Friday 3 would be this. Just weird that this is 5. I just do not understand it. Is it actually 5 or is it 24 and EAX +4? Just wondering if this is actually 4, but it's I wonder if there's a way to get that to be. Anyways, okay, so setting that and then returning 0. Okay, v5 is the value. So it's an int. So we had it to be what, 255. Oops. Thermostat night Friday 255. Let's go 2 to the 32. -1. Okay, so we can set to negative values. It will print that out to us. Let's check. Where was I? Time, date, temp. And then return. So this was set therm. And where'd that debug? Okay, that debug string says set thermostat to temp. But what if we get it without reading it? Get. Okay, is that returning anything? Oh, read. $253. Okay, interesting. Okay, reading. Let's just write into there. Arg. So first argument I plus 16 v3. Okay, cool. Now we're cooking with fire. Okay, so this is returning. Let's look up the IDA shortcut. Enum. Enum member M. So I should just be able to hit M. Sick. M. Oh, that is, oh, that's 0. Okay, great. So if we call thermostat read, okay. So if we call thermostat read, if it's 2, then get the third argument's I times 2 plus I plus 16, dereference it. Again, this was, I think, args 0 is the object that gets passed in. It's my guess. Okay, if args 2, then thermostat MVR decrement args. Oh, because we're reading it. Yeah, so this is the read. Oh, interesting. Okay, so how do we then do arbitrary ones of these? Because we say read night Sunday, and then it just takes that I And then, oh, interesting, high byte or low byte. Ah, okay, so this is what's setting it to be the thermostat that we're reading from. Okay. Cool. See, this is what I love about as you do more and more of this. Like, I know that this chunk here, I can just in my head translate to basically returned v3 as an integer. And that's where that return value comes from. So that I know when I have read. So when we're calling, where's do read? Or get therm. When we're calling that, we do this processing, date, day, time, date. And then we eventually call this read method. Was the two passing in two arguments, so passing in a date and a time. And then, yeah, so now that we know that that comes back, and then we return that value, and that's what's then, so it's in read, right, get therm. And then after that, the results in temp, it should get printed out, I think. Yeah, okay. So then let's see if there's a way, from what we can understand here, that we can actually mess with this, because this basically, so this is doing absolutely no checking on reading from values. So if we can do arbitrary values in here, then we have an arbitrary memory leak, which would be a great primitive to one great primitive to start with. And the other one, the thermostat write, looks like it doesn't do any bounds checking either. The problem is it's definitely messing with our input here, right? Because we saw that we had to now the interesting thing is this time. Okay, so let's look at this. Invalid. Okay, so therm. Read day 10. That's super weird. Why can't I put in an integer there? Maybe I've already solved my problem. Invalid date. Oh, okay. So this is like backdoor functionality that we can, rather than say like read Friday, Saturday. Okay, let's look at this. Whew, okay, so now trying to reverse engineer this. I guess I can try. But man, my Ruby's real rusty. Okay, so this has local variables S. Is that a local variable called and? It's command time date. So move whatever was in R1 into R6. I think that's how you read that. Load then the space into R7. Split. So split. Okay. Let me open up a Ruby guide. It's been a long time since I did Ruby on Rails. Ruby define method. Is it just like that? Method name. Get them. Let's see. Yeah, it just moves line into there. So I think it just calls, yeah, passes line as, but this is S. So then it's, let's see, send split. Okay, something like command equals S dot split. Okay, let's increase this font size for all you fine people. And then let's, man, do I, yeah. IRB. Great. S is equal to, this is going to be, I don't know if it's the whole command or what's after it, but we can probably figure that out. I bet it's something like this. Okay, great. So split it, move R6 into R3, load I2. I think, does that just mean load immediate? Let's see, Ruby opcode. Size of operands, instruction table. Oh, this just loads it to be 2. So just what we thought, load immediate 0, 1, 2, 3. Okay. Okay, load 2 into R7. Send R6. So result here, bracket 2. So I think that means, wait, why the hell? So it doesn't like my 6 syntax. Ugh, because you don't need this fucking thing. Syntax. Why does it matter? Okay, time is equal to cmd2, I think. It's loading that into there. Send, oops. Okay. R6 to I. The R6. Okay, split. Where do the results get set? I feel like I got a good hang of this. R6 into R3. I know the 2i method. Oh, let's see. Oh, if maybe something like this, if time.2i is not equal to 1. Oh, I forgot Ruby has these stupid. Okay, so then if not, so if it is equal to 1, so this is why we're able to use that time in there. I think our second one can be time. All right, I think this definitely is our vulnerability. So let's see. Time into R6, 2i, move R6 to R4. Okay. Let's see. Oh, yes, it is read day Friday. So read day Friday dot 2i is 0. Right, so if this, this would probably be else. And jump if not, bang. Wait, but why would it be? It's not equal to 1. No, if it's not equal to 0. I feel like then it should jump somewhere. Okay, move command into R6, load 3. Okay, date. Looks like it's command 3, but that doesn't quite make sense. Date, so time. Okay. Similar thing of 2i, 0. Interesting, okay. Oh, this is like another parameter, I think. Let's see. Day, date, time. Huh. Yeah, this guy's been holding out on us. Okay. Invalid date. Valid time. So times definitely should be that first value, if I'm reading this correctly. So time, so something like, I think S should be probably, yeah, and command S dot split, and then command, so now command 2 is day, and 5. And we can call, yeah, okay, great. Okay, so this is, oh, there's more parameters. Okay, so 3. And 3 is Friday. That's interesting. Okay, so if I'm reading this right, so command time date. If it's not an integer, then wait, this must be, this is the comparison on date. If it's not, so this is, if it does equal 0, then set the date to be this. So this is probably why. Let's see if we go in here. We said day. What if I said 10? I didn't say anything. Valid date. What? Okay. Oh, wait. Let's not. Send 0, move. This is another if. If date.2i is. Why is it checking this? Okay. If it's greater. If it is greater than that, then This is definitely different than what happens in that other one. Okay. So if it's a string, okay, so basically next is like if time is a string, if time is a string, then check invalid time. Fascinating. Oh, I see. Time of day. Invalid time. Okay, so that's why when we say read when we say read day foo, it says invalid day, but if I said read day 10, all right. That would be 0, 1, 2, 3. Yeah, so I think this does get in. I think I was wrong here. I think this is okay. Okay, so this checks if it's not a string. Cool. Okay, so I can definitely test this theory out, and I'm verifying this, as we can see, by okay. So if I say read day fry, it'll tell me invalid day, but I want it to tell me invalid time. Oh, time is this one. 0, 1, 2. That would make sense. Does it mean invalid time? Okay. Wait, 0, what? Okay, this. Okay, date is definitely day of the week. Okay, I'm just looking at this here. Okay. Does send back FF. That's interesting. Oh, let's see. Is that a valid? If I go. No. Ah. Okay, so it won't interpret that as a 16-byte number, but it definitely will. Okay. Invalid time. Why does it call it invalid time if it is not? Oh, because there's another check for invalid time. Sweet. Okay. So these checks, this check for invalid time, this check for, okay, so this whole thing is a valid time, this whole thing is a valid day. Ugh, I didn't see that there's other things down there. Now, move time. If it's less than R6. oh, if the time is less than R6, go to there. Okay, so if it's less, time is less than 0. So if I said this, move time into R6, load 1 into R7, jump if greater than operation. Okay, we definitely want to do that. Times. Hey, sorry, I just saw your message. Is there any best resource for assembly? Yes, great question. If you want to get better at learning assembly, I would highly recommend you check out Pwn College. The class is going on right now. It's a class at ASU, but you can join it now. And there's all kinds of, you can check out the dojo here, and you can do 365 or 466. If you're just looking to get into assembly in 466, there should be some modules in there. Yeah. So in this assembly crash course should get you up to speed. But yeah, this is one of the best ways that you can actually get improve your assembly skills. Highly, highly recommend it. Thanks for the question. Feel free to ask any more. As I was not understanding. Okay, so. Oh, because this needs to be 1 or 0. I see. The first one this time. So it can be 1. Okay. Okay, if it's less than 0, then I think go to invalid time. And then if it's, okay, if it's greater than 1. We can do it with just 1. Okay, whew, there we go. Cool, and by incrementing this number, it looks like I'm able to read farther and farther out. Well, the problem is, why doesn't it crash? But let's see. So invalid date, so move date, R5 into R6, load immediate 0 into R7. If it's less, date is less than 0. I don't understand. These look like the exact same checks, but with the date. Yep, it does look like that, but it seems to be accepting them, so I will just ignore that for now, okay? Oh, date. Okay, great. So then we get date, time and date into there. Sweet. Call read. So now, ooh, wow. There's actually a lot. Was this an hour and a half to get to this? But I think we now have an arbitrary file read. So we should be getting, yeah, so arg3. So this argument, args2, are day. And I think we can just change this to like day. Oops. Let's see this. Because I'm reading out a byte at a time. Cool. So I can use day or night there to flip between those and be able to get the high and low bits here. So this args2 must be day, and let's check here. So first is time. That one was time, and the next one was date. So therm op time date. Okay, let's put this in notes. Okay. Can pass in integers, which are then used to access likely can use this to leak out memory. All right, sweet. Thanks for the question. This is IDA Pro, so I actually have a license that I pay for work because we use it in our research and stuff. So that's why I have IDA Pro. I believe for this as 32-bit IDA, it should probably work for IDA freeware, so you should be good there if that's what you need. You can also use things like you can use Ghidra. I know some people like Ghidra, or Binary Ninja, or even anger management. Oh, see, this is what used up all that memory. All right. All right, now let's see. I think before, one thing I need to start doing is saying like, okay. So we could probably then verify if this same behavior exists here, right? So this is probably an arbitrary write. So we can test this to see if it crashes. I bet it's using the same logic in write. So rather than reverse it fully, let's just throw that in there. Let's see. I get that right there. Okay, now that's weird. I can't write there. Unless, oh, because of course it's not right. It's called set. Invalid date 100. Okay, so then let's check this disassembly. Now that we have more of a handle on this. This was get therm. Set therm. Okay, I knew set came from somewhere. Oh, yeah, set. Okay. So split on space. Okay, command time again. Call to I. If it's jump here, if it is equal to 0. Okay, yeah, that's good. So that's a check, just like we had before. Okay. Yeah, so setting it, moving time, so setting time to be I2 if it's an integer, or 2I if it's an integer. Okay, then move command, right, get date. Okay, 2I if it's not equal to 1, otherwise I'll jump here. Okay, I think that's roughly the same. Command, put 4 into there. Oh, because that's the value we want to get. Yeah, so this is going to be this 2I. Temp, like, what if it's temporary or like the actual temp we're trying to set. I think that's what it's more about, temperature. Okay, time. Class string, if time is this. Okay. Yeah, same thing. So jumping over there, it's not be exactly the same, but if it's a string, if it's not a string, time. Not equal to 1, an invalid time. My problem was set. Let's see, therm set. Invalid date 1000. Okay. Let's check this. Move date there. Get size of the week. Size. Oh, so there actually is a check in here for writing. That's weird. Huh. So vulnerability looks like, at least for the memory leak, is that it's not in here. And I don't think this firmware actually read the flag, so it's not like we can read a flag out of it. So I guess we didn't see, but I would assume it's not reading the flag into memory. But always good to double check these things. Nope. Okay. So it doesn't look like it. I mean, it's possible, but unlikely. Okay. So invalid date. Day of week size. Although if it's less than or equal to this, then it will use it. Okay, so okay, interesting. What if I so now I'm trying to use negative numbers to get around this check. I think that's what it's doing. So it's setting negative values. Let's see, what about like something like this? And 2's complement. Oh God. Would that be, let's say I want a negative large number, so I'm going to 2's complement that. Yeah, I just want this to be a 32-bit number, but okay, 4, so OX4. Yeah, so what I want is, negative, let's try this. I'd really love for this thing to crash. Okay. There must be a way. Ruby. I want to see the output. 2S. Oh gosh. Okay. 2S16. Yeah, okay. That is what I wanted. Okay, so now I think we can write negative offsets of here. I think we should be able to do this and be able to write and pass in for this one. Yeah, for our, oh no, this is the value that we're writing. I think, yeah, this one should be our, this is like temp. This is, I think, day and time. So let's see, which ones are they, what order are they passed in? Time, date temp. So I'm pretty sure this is temp because obviously it's what we're writing. So then the first most, if this is probably time. This is probably date, is my guess. Cool. 2 times date plus time, and then if arg2, so this is the but this should be arg2 be the 1 or the 0. Temp. Okay, I'm not quite certain. That's not right. Okay. Cool. Question is, can I get it to, or why didn't it crash? Right, because we're writing a byte at a time. Yeah, so arg2. So this is not actually time because time 2 and then date 3. I don't know why temp is 5. It just doesn't make sense to me. This is a pointer into the thermostat area. Yeah, that's definitely where that is. Right, because this arg_i, it's using the first argument, which is probably our object, and it's dereferencing into that 16. So what we need to do is figure out, so we even, like there, 2, 1 plus 16, I bet this is a args. I think so. Let's check the that code we were looking at. UART new. Yeah, so new gets passed in a varg just the same. And then calls mruby instance new. So this is something we're going to have to figure out. It takes 2 arguments, the size, or no, the VM. So where does this get passed in? V1 gets passed in here. Size. Yeah, and then this sets this UART handle, the instance data. Okay, cool. So yeah, we must have to look for like instance data and all kinds of junk in here. But okay, so it's actually, so let's see, notes. It's been something I've been doing recently that's very helpful. Okay, so we have arbitrary read from plus or minus offset through. So the cool thing about this is it shows that, like, okay, we just looked at this thermometer, and we found bugs there. There's probably bugs in all the other functionality too. So like as we weaponize this, we would have people look at those other ones. So we think we have an opportunity through thermometer read, specifying integer value for time, for date. We also have, I think we have very negative writing through thermometer right. And now this way, when we come back, it won't be so disarming. I have to rethink everything from scratch. Okay, where? Flow you. Oh no, did I get rid of that? So it was, well, I can do it again. Let's see, it was therm set day, let's say -1,000. Okay, now I said oh, but that only reads 75 and not 20. What the heck? No, but the problem is I'm writing bytes, so I can't write too much. All right, well, we'll just have to figure that out. That's probably why. All right. Cool. All right, so I'm gonna stop here. So we found some bugs, and next time we will try to exploit them. I think what I'll do offline is probably try to get it to a point where I can debug this and run this, because the problem right now is I can't run this at all, so I have no idea of how to debug it, how to figure out what we're actually leaking or not leaking. So anyways, I'll be a little bit more prepared with tools, but thanks everyone, and thanks for sticking around and chatting.